your name, your full name off of it in case it's in it. Just put like your first name, just because this is gonna be on YouTube.
Oh, you have to, I think, let me in first.
Yes, I do. All right. Sorry, give me a second. I'm not used to doing this only on my iPad. All right, let's see. All right, you're in. All right, you good? Huh? Yeah, good.
Is just my first name fine?
Yeah, it's fine. All right, can you see it okay on there now? My screen? Okay, so we're going to talk about, first of all, finding inverses. So they want us to verify that these are inverses. So to verify it, what we basically have to do is plug in g of x into f of x using functional composition, and plug g, or f of x rather, into g of x. And both of those have to be equal to just x, the identity function. Okay, so let's do that first. Let's do that together. In fact, let me color code these again, because I feel like that's nice to do. So let's do g of x in blue. Oops. G of x in blue.
Should I do it on my notebook?
No, it's all good. You can just watch and it's being recorded, so you're good. So g of x is blue, f of x is red, so you can understand how I'm doing it. So first I'm going to plug g of x into f of x. So I'm going to write f of x out. So f of g of x equals, every time I see an x, I'm going to leave it blank because I'm going to plug in g into there, right? So g of x, which is 3x plus 5 over 1 minus 2x, 3x plus 5 over 1 minus 2x. There's g of x. Okay, so I plugged it in, and now let's just simplify it. Now to simplify this, what I prefer to do is clear the fraction. So you see how I've got this denominator here on the top and the bottom. If I multiply the top and the bottom by that, it's just a really good way to simplify this. It makes it much simpler to do that. But in order to do that, I have to distribute it in, right, to here. You follow? And also to here. So when I do that, this is going to cancel with the bottom, right?
Yeah.
And on the bottom, I'm going to get that 2 is going to stay there, and the 3x plus 5 is going to stay there, but that and that are going to cancel. Got it? And then also on the bottom, I've got to multiply that by the 3 here. So got to multiply it by that, right? So multiplying those together, I get 3 times 1 minus 2x. Okay, same thing on the top. When I multiply this into here, the top and bottom cancel, so I just get 3x plus 5. And when I multiply this to here, I just get minus 5 times 1 minus 2x. Okay, so I'm just going to clean this up. So this is, I'll do this in green above it. So this is negative 5 distributing plus 10x. Got it? And this is 6x plus 10 plus 3 minus 6x. So adding those together, 3 and 10x give me 13x. Negative 5 and positive 5 give me 0. Got it?
Yeah.
And on the bottom, 6x and minus 6x is 0. And 10 plus 3 is 13. Whoa, how about that? And what cancels?
The 13.
Yeah, so I just got X. So that worked, but I've got to check the other one as well. So now I'm going to do the blue. Now I'm going to plug in into G of X. I'm going to plug F of X into G of X. So I'm going to write my G of X out, but leave a space every time I see an X. Right, leave a nice big space, because now I'm going to write in my F of X, this red one. I'm going to write that in for X everywhere, because that's what functional composition means. That make sense?
Mhm.
So X minus 5 all over 2X plus 3. So let's do the same thing. What am I going to multiply by?
2x plus 3.
Good. Has your teacher taught you how to do that?
Yeah.
Clearing the fraction? Good. Some teachers don't do that. They make you just do like common denominators, and it's kind of a mess to me, if you ask me. So I'm going to do that same thing, multiply that in, multiply it in here as well. When I do that, I'm going to get, I'll just do this quick now, 3 times X minus 5, because the 2X plus 3 cancels, right? Plus 5 times 2X plus 3. That's the top. On the bottom, I'm going to get 1 times 2X plus 3 minus 2 times X minus 5. Same deal, I'll do simplifying with green. So this is 3X minus 15 plus 10X plus 15. And on the bottom, it's 2X plus 3 minus 2X plus 10. And so those simplify to 13X on the top and 13 on the bottom. And that equals X. And therefore, they are inverse functions. Okay, good. Questions about it, what I did?
No.
All right, good. It says find the inverse. All right, so now to find the inverse of a function, that's a little bit of a different process. What you do is you take your X's and your Y's and you interchange them. So that, remember, F of X is your Y. So you interchange them. So you're going to write X equals 2Y plus 3 all over Y plus 2. Every X became Y, every Y became X. And now just solve for Y. So multiply both sides by Y plus 2. Got it?
Mhm.
Distribute the X. XY plus 2X equals 2Y plus 3. Move the Y's to the same side and move the things without Y's to the opposite side. So I'm going to do that in one step. So it's XY minus 2Y. I subtracted 2Y. And I'm going to subtract 2X as well. See how I did that?
Yeah.
Factor out the Y. You get X minus 2. And now divide both sides by X minus 2. 2X plus 3 all over X minus 2. And then write it as F inverse of X equals negative 2X plus 3 all over X minus 2, as long as that's a function, which it is. It is a function. Okay, good. No questions about that?
No.
All right, determine the domain range and horizontal asymptote. Okay. All right, so these are exponential functions.
Yeah.
So I'm going to write this so that it's easier to understand what this is. Basically 3 to the negative X minus 2. This one is 2 plus 3 times 4 to the X. And this one is 7 minus 3 times e to the negative 2x. Okay, so the domain, the range, and the horizontal asymptotes. So, well, to graph these, it would maybe make the most sense to graph them. So let's just look at what the graphs look like for each. Remember transformations? So your basic graph for an exponential, like if it was 3 to the x, I'll show you what that looks like. Y equals 3 to the x would go through 0, 1, and it would, the asymptote would be your x-axis, and it would go up like that.
Mm-hmm.
When you make the x negative here, that, remember, making the x value negative flips it over the y-axis. Do you remember that?
Yeah.
So this is actually going to do this. It's going to go that way. And then -2 is going to bring the whole thing down 2. So my equation is going to be, I'll do this in yellow. So my equation is going to be flipped and everything's going to move down 2. So the asymptote will be moved down 2. So there's y equals -2. Got it? This point gets moved down 2. So that's instead at +1, it's at -1 because it moved down 2. But everything else stays the same. So you still have this, whoops, it flipped, remember it flipped as well. So it's going that way. And this is going this way. So there's your graph. So let's answer the questions. What's the domain? Well, the domain you can see is all real numbers. Can you see? Here's how I like to do domain. I'm looking at the yellow graph. I think about what X values are going to be touching the graph. So I scan vertical lines from left to right, and I ask, am I going to touch the graph, the yellow graph way over here? I am. It's going to take a while, right? Because it's exponential, but I'm going to touch it, right?
Yeah.
Am I ever not going to touch it by doing a vertical line scan?
No.
Never. So the domain is all real numbers. What's the range? Well, instead of a vertical line scan, I do a horizontal line scan from bottom to top, and I ask, am I going to touch the graph? No, 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 no. Yes, everywhere above -2, not including -2. So the range is from -2 to infinity, not including -2. So it's an open parentheses, right?
Yeah.
And the horizontal asymptote, I already wrote it there. It's y equals -2. Okay, see how we did that? So let's try this other one. This other one I'll do in green, and I'll use the same graph. Now I know the graph is a little bit different. It's y equals 4 to the x, but it's basically the same thing. It's just a little bit. 3 to the x and 4 to the x aren't very different. It's just stretched a little bit more. You understand that? It's still going through 0, 1. So I can actually say for this, I can say 3 to the x or 4 to the x or even e to the x. They're all pretty much that red graph. They're a little bit slightly different, but this point is not different and the asymptote isn't different. Make sense?
Yeah.
So I can use that same one. So this green line will be my equation. And notice what I'm doing. I'm stretching it. That 3 stretches it vertically. So it's like this. It's still going through that same point. It's just stretched. So it's like that. But it's roughly the same shape. This 2 moves it where? To up, right?
Yeah.
So my horizontal asymptote is y equals +2. Got it? And this new point is still going to be right there, and it's just stretched up a little bit. No big deal. Doesn't really affect.
0.
Say that again. Yes, correct. That point is 0, 3. Correct.
Yeah.
But the asymptote is still 2. So what's my domain for this one?
Negative infinity.
Good. What's my range?
2 to infinity.
+2 to infinity. Makes sense. And my my horizontal asymptote is y equals 2. Okay, y equals 2 is the horizontal asymptote. So this last one, let's see if I have a color left I can use. I've used red, I've used yellow, blue. So this one we'll do in blue. Hopefully you're not colorblind because that looks a lot like the green if you are. So what's the difference between this, the red? It's still the same graph essentially. But what am I doing here? Well, this -2.
It's a reflection over the y-axis.
Y-axis reflection. And the 2 part of it stretches it basically. It either stretches it or compresses it, depending on where it is. A vertical stretch is the same as a horizontal compression. That makes sense? Think about it. This one right here, this red one, if I stretched it vertically, see how I'm stretching it vertically? Isn't that the same as compressing it horizontally? It is, it's the same. So a vertical stretch and a horizontal compression are essentially the same thing. So it kind of depends on where you're doing. We're kind of doing 2 things. This is gonna stretch it because it's bigger than 1. That's gonna stretch it. stretch vertically. This negative here does what?
It brings it down
Flips over what?
the x-axis.
So that negative flips over the y-axis and it stretches it. See, is it going to stretch it? When it's 2 with the x, is that going to stretch it or compress it horizontally? If you square something, it goes up faster. So this is actually going to be compressed. This compresses horizontally.
So does compression mean it like gets bigger? Or?
Compression horizontally is the same as stretching vertically. I actually prefer just to think of it as vertically speaking. It's a vertical stretch. It's basically it's stretched even more vertically. Think about if you have 3 to the x, and if you multiplied that by 2. When I plug in 1, think about when I plug in like 2 here for x. What did I just do when I'm plugging in 2 for x? For x, if I plugged in 2, now it's really 3 to the 4th, which means it went up even faster. So putting a 2 here is basically making it vertically, it's vertically stretching it. But remember, I said that when it's with the x, a lot of times teachers or tests want you to speak in terms of horizontal stretching and compressing. Well, a horizontal compression, think about this red line. If I compressed it horizontally, that's the same as stretching it vertically. Can you see what I'm saying?
Yeah. So
technically it's a horizontal compression, but that's really just a vertical stretch. So these are both stretching it. So basically it's just going, but to be honest with you, it doesn't have any impact really on our graph because they don't really care. We're not even really looking at we don't have any points in here or anything like that. But the only point that matters is this point. And the only line that matters is the horizontal asymptote. So what's being changed? This 7 does what to it? That moves it up 7. So that's going to change, right? It's going to be up here. So there's my new my new horizontal asymptote, excuse me. Y equals 7 is my horizontal asymptote. Y equals 7. And what happened to and it flips how?
It flips both over the y-axis and x-axis.
That's right. So it's going to be here. Actually, you know what? I think I made a mistake. This, it stretches it vertically, but it also affects this number. I did make a mistake. This stretches it vertically, but it also moves that point. So actually I made a mistake for the green one. It didn't change any of my answers down here, but this point isn't going to be there. It's not going to be 3, 0. It's going to be multiplied by. So instead of at 1, it would have started at 3, but then it's also shifting up 2. So it's actually going to be at 5. This point's going to be 5. I'm going backward to look at this green graph. Now I'm regretting doing them all on the same graph, trying to save space. But that's really at 5.
Wait, why is it at 5?
Because this 3 here. Think about plugging a 0 in. When I plug in 0, what's this going to equal? 1. And what's 1 times 3? 3. So that's it actually got moved up. When you stretch it, you also stretch this point.
So it's because of the 4?
Nope, doesn't have anything to do with the 4. Because when you plug 0 in here, it doesn't matter what your base was.
Oh.
Right? When you plug 0 in, 4 to the 0 is 1. But now that's 1 times 3 is 3 plus 2. So your handle, I like to call this the handle. Your handle actually moved up. Your handle would have been at 3, but then it's also got shifted up 2.
So it's because of the 3.
Correct. It's because of that scalar. It's called a scalar, the factor that's being multiplied on the outside. So this graph is doing this. Do you see what I mean with the stretch?
Yeah.
And the green graph, so I'm sorry, the blue graph, this graph, same deal. When I plug in 0, it's good sometimes just to plug in 0. Because this thing still is 0 right here then. You see it? And this whole thing becomes 1, so that it's -3. But then you're adding 7 to it. So the point, the handle that I'm dealing with is going to be -3. It's going to be 7 minus 3, which is 4. The point is at 4, right?
Yeah.
But you're hold on one second. I got to go back to the green one now, because now I've got to deal with the horizontal asymptote. Oh, the horizontal asymptote was still right.
Yeah.
The horizontal asymptote was still 2. So what's the asymptote going to be for this blue graph?
7.
Yeah, it's still going to be 7. So there's my equation up there, my green line. But the difference is it flipped over twice. It flipped once this way, and then once. So it was going like this, and then it flipped over the x-axis as well. So it's going like this. Now, if you're not sure that you did that right, plug in a point just to make sure you did. So that's what I'm going to do. So let's plug in 1 and see what we get. When we plug in 1, we should get a number. Actually, let's plug in 3. We should get a number that's smaller than 7, but a positive number smaller than 7, 6 point something, right? So plug in 3 here, and you get, and you can just do this in your calculator if you wanted to. You get -2 times 3. So it's e to the -6, which is like 1 over
e to the 6.
That's right. So it's like a small number, right? So when you multiply that small number times 3, what's it going to do?
It's going to be 3 over e to the 6.
It's going to be 3 over e to the 6, which is, again, a very small number, right? It's just a small number. And what's 7 minus a small number?
An even smaller.
No, what's 7 minus a small number? It's really close to what? It's really close to 7. So it's 6 point something. So I actually don't even have to find the exact value. I know in my head, oh yeah, that makes sense. I did it right. Whereas if you plug in a -2 or -3 or something like that, this becomes what? What happens to this number?
It becomes positive.
Positive, which means e to that positive thing is a big number, which means this is a -3 times a big number. And who cares if you're adding 7 to that? It's still going to be a very big negative number, which means it's going down like that. So that checks out. That makes sense. All right, so we're good. So let's do the domain. What's the domain going to be?
-infinity to infinity.
Good. What's the range?
-infinity to 7.
Good. You can see that. Good. Excellent. Not including 7. Perfect. There you go. All right. All right. Let me see if I can end this.